Good day everyone. This video presentation is a course requirement of the graduate school in the subject Math Analysis for Teachers under Dr. Jess Pizarro of St. Paul University, Philippines. By the way, I am teacher Wendy Faye Basco and welcome to my channel. And today, we will talk about the derivatives of the inverse trigonometric function. The derivatives of the inverse trigonometric functions can be obtained using the inverse function theorem. Using this technique, we can find the derivatives of the other inverse trigonometric functions. Now, in finding the derivatives of the inverse trigonometric function, you're going to have a new set of formula for the inverse trigonometric function different from the derivative of a regular trigonometric function. So you can see that we have different set of formulas that you need to memorize so you can perform the derivatives of the inverse trig function easily. So there are 6 functions and we have 6 rules. They look complicated, but don't worry. There's just only 3 rules you have to remember, and that's sine, inverse tangent, and inverse secant. As long as you memorize these 3, I am sure you can memorize the other 3 as well, because they are exactly the same, but these actually have negative part. And a good way you can connect these two is sine and its co-function cosine. Those are the ones that are the same, but cosine has the negative part. Same as with tangent and its co-function cotangent, in which cotangent has the negative part, and also with secant and its co-function cosecant. Now let's have the first example. In this case, we are going to find the derivative of y equals the square root of tan inverse x. Before we can use the formula, we always simplify the function into an exponential function so it's easier to derive. So in this case, the derivative of tan inverse of x raised to 1/2 requires chain rule to be able to simplify our function or to find the derivative of the function. So u is tan inverse x, and the derivative of that one using the formula is 1 over 1 plus x squared. And using chain rule, y prime is equal to 1/2 times u, which is tan inverse x raised to 1 negative 1/2 times du, which is 1 over 1 plus x squared. Now, this derivative right here is already acceptable because you perform chain rule and you also use the formula for finding the derivative of tan inverse. So for us to simplify, we know that this is a negative exponent, so we'll put it down here in the denominator. So the final answer now is y prime is equal to 1 all over 2 times the square root of tan inverse x times 1 plus x squared. Let's have another example. We need to find the derivative of f of x equals sine inverse 5x. So we're going to use the set of formula for the derivative of inverse trigonometric function again. F prime of x is equal to the derivative of sine inverse 5x with respect to x. So u of sine inverse is 5x and du will be 5. So to use the formula for the derivative of sine inverse x, we have 1 over the square root of 1 minus u, which is 5x squared, and just simply substitute the value of u, which is 5x, times the derivative of u, which is 5. Now, if you want to further simplify your derivative, it will turn out to be f inverse of x is equal to 5 over the square root of 1 minus 25x squared. Okay? Now, the third example seems a little bit complicated compared to the other two because in here we are using the product rule and we are going to find the derivatives of two functions here, which is f of x and g of x. Okay? So, since we are working on secant inverse x, we are also going to use the derivative of inverse trigonometric function. I change my radical into an exponential function, so I have f of x is equal to x squared minus 1 raised to 1/2 times secant inverse x. Using the formula, it will give you using the product rule rather, I simplified all the terms so you can see all the steps are working. So f prime of x is equal to copy f of x times the derivative of g of x plus the derivative of f of x times g of x. Then let us simplify your derivative. Copy the first term times the derivative of the secant inverse x. Using the formula, it will give you 1 over the absolute value of x times the square root of x squared minus 1 plus the derivative of x squared minus 1 raised to 1/2, which uses the chain rule again, and that is 1/2 times x squared minus 1 raised to negative 1/2 times the derivative of the inside, which is 2x multiplied by secant inverse x. To further simplify, we can combine these two together. That's why we have square root of x squared minus 1 over the absolute value of x times the square root of x squared minus 1. Plus, we can get rid of 1/2 and 2. That's why we're not seeing 1/2 and 2 here. So, this is a negative exponent. So, I place it here in the denominator. And secant inverse x is positive. So, it's also right here. So that's the final answer. F prime of x is equal to the square root of x squared minus 1 over the absolute value of x times the square root of x squared minus 1 plus x times secant inverse x all over the square root of x squared minus 1. So that's all for today. Thank you for listening, and I hope you learn a lot today. Happy learning. Thank you.